Hello and welcome to a quick demonstration of Computer Aided Robotic Welding. Let me give you a brief info as to what this actually is. Well, we've been working on a solution that gives users the means to review and fix robotic welding output manually. In the absence of the following functionality, sections of welds could fail to export to robotic welding due to a failed normals calculation. Previously, there were no means available to address the failed section of a weld, and as a result, this development focused on creating a solution that makes it possible to calculate normals perfectly every time. Users essentially can run a set of commands to show or hide, adjust, and save the weld normals manually. Calculating accurate normals is essential for computer-aided robotic welding. Our solution gives users the means to review and fix robotic welding output manually. Okay, well, let's get right down to it. As you see, I have a drawing open. This drawing contains some welds. However, there is no easy way to tell if these will produce good output or not, and which of them might be skipped when welded. Way to do it now is to use this new command that we have. So I'm just going to type it down, SCAD. So SCADV weld normals show. I'm going to press enter. It's asking me to select welds. I can specify which welds I want, or I'm just going to type all. Should select all welds and hit enter. Let me zoom in a bit and I'll show you what I mean here. So we're going to use the terminology normals. And what is normals? Well, essentially, normal vector that comes out of the face of a surface of two welded parts perpendicular to surface face. This is what we refer to as normals. As you can see, some normals show as blue, which are good. They were calculated fine, successfully generated. The ones that show in red were the ones that we could not successfully calculate. So they're defined in as red in here. So let's zoom out a bit and then see if we can find a weld that we can work with or try to fix in here. So we have quite a few that are in blue. I see there is something in red over here, for example. So I'm going to zoom in. And I'd like to focus just on this weld. So for that, I can select this weld. And we have an option here, which is isolate. It's going to remove everything else other than these two faces that I'm going to be working with. So what I'm going to do next is I will use another command that we have, which is SCADV, and it's ACADV weld normal to face. What it wants me to do next is to select a face perpendicular to which I want to adjust the normal. So I'm going to select this face, and the next thing I'm going to do is I'm going to select this normal right at the edge here, and it automatically adjusts it perpendicular to this face. As you can see, this normal turned to this mango orange color. I'm going to do this to these two as well, and they get adjusted automatically. You essentially would continue doing that until all of your welds are fixed. I don't want to take up all of your time doing that, but that would be the process. For the purpose of this exercise, I'm going to end isolation, and I will zoom out a bit. The next thing we would want to do is to make sure that we save all the manual adjustments to normals. And to do that, we have another command that we can run, which is scadv weld weld normal save, and it's done. Another command that we have allows us to hide all of the normals here, and that is scadv weld normals hide. It's going to ask us again to select the area. I'm going to say all, and now all of those normals are hidden. So last but not least, if you were to delete a weld from the project, you might want to run one more command that will remove obsolete data from previously saved normals. The command for that is scadv weld normals purge. Normals purge. I mean, I haven't had nothing deleted, but it would remove all of those obsolete data for you. And that concludes this demonstration.